I want to make sure everybody's clear on what one-to-one functions and inverse functions are. An inverse function is a function which undoes what another function does. When we're solving an equation, especially a linear equation, what we do is we go through, and if it's multiplied by 2, we're going to divide by 2. If it's got 5 added to it, we're going to subtract 5 from it. For instance, if we had 3x minus 4 equals 5. So what we're doing over here, if we plugged a number in, we would multiply by 3 and subtract 4. The inverse of that is to not only change multiplication and to division and subtraction to addition, but also to reverse the order. So the inverse of this would be to add 4, because before the last thing was to subtract 4, so now the first thing is to add 4. And then instead of multiplying by 3, we would divide by 3. And that would solve this for x. We would add 4 to both sides. And then we would divide by 3. So we will have undone everything that was over here with the x. Inverse functions work the same way. As a matter of fact, literally, the inverse function of y equals 3x minus 4 would be y equals x plus 4 divided by 3. This is the inverse function to that. The notation we use for a regular function is f of x. The notation we use for the inverse of f of x is this f with the little -1 up here. This isn't actually used as an exponent. It simply means the inverse of f. So if f of x is 3x minus 4, the inverse of f is x plus 4 over 3. Now, you know, I hope, that a function, the definition of a function, anything that creates a set of points is a relation. So if I had 2, 5, 3, 4, 2, 6, this is a relation. Anything that creates a set of points in math is a relation. If I look at this, if I've got the points 2 and 3, well, that's just 2 again. 2 and 3 are in the domain. And then 5, 4, and 6 would be in the range. So I could say, well, 2 maps to 5, and 3 maps to 4, and then 2 maps to 6. This is a relation, but it is not a function, because a function is a special kind of relation in which every domain element maps to one and only one range element. And because the 2 maps to 2 different numbers in the range, this is not a function. Suppose we had a set consisting of 2, 5, 3, 5, and 4, 5. So the domain for this one consists of 2, 3, and 4. The range for this one consists of 5, just 5. So the 2 maps to the 5, and the 3 maps to the 5, and the 4 maps to the 5. And because the definition of a function is a relation where every domain element maps to exactly one range element, here's our range, this is a function. However, this is not a one-to-one function because all of the domain elements are mapping to the same range element. And to be a one-to-one function, both all the domain elements can map to only one range element, and every range element can only correspond to one of the domain elements. So in order to be one-to-one, we have to have a situation where perhaps 2 maps to -2, and 3 maps to -3, and 4 maps to -4. So that now for our domain, we've got 2, 3, and 4. And for our range, we've got -2, -3, and -4. And you can see that this is one-to-one. You can figure it out from the set, but a picture's worth 1,000 words. This one is not only a function because every domain element has only one line coming out of it, but it also is one-to-one because all the range elements only have one line coming to them. Now for the inverse function to exist, it has to not only be an inverse, but it has to be a function. For the inverse function, you switch so that all of your range elements are now your domain elements. So for the inverse function here, the range becomes the domain. So the inverse would have -2, -3, and -4. The range would now be the old domain, 2, 3, and 4. And where the domain before mapped from 2 to -2, for the inverse will map from the -2 to the 2. Before, the domain took a 3 and spit out -3, and for the inverse, the -3 has to spit out the 3, and so on. So first of all, in order to be a function, when you turn this around, you still have to have a situation where every domain element only corresponds to one range element. And so where this could have been a function, even if the 2 mapped to, or even if different elements from the domain mapped to the -2, when we switched them, that would then make the -2 map to more than one element in the new range. So it has to be one-to-one to have an inverse function that exists. To be one-to-one, you can recognize it on the graph. On the graph, you have to see that it only increases or decreases. You have to have a function that when you look at the graph either only goes up, which would be 1-to-1, or it only goes down. That would be a way to show that it was going to be 1-to-1. It must pass the horizontal line test in addition to the vertical line test. The horizontal line test is where, if we had a graph like this is a function because it passes the vertical line test. So it's a function. But it doesn't pass a horizontal line test. So it's not 1-to-1. Another way to show it's 1-to-1 is that if f of A is equal to f of B, then A has to equal B. All of these are just different ways of showing that it's a 1-to-1 function. So those are different ways that you can recognize whether a function is going to be 1-to-1. And only if it is 1-to-1, then can it possibly have an inverse that's a function.